Hello students, today we are going to solve word problem of quadratic equation based on speed, distance and time. So let us tackle the first sum. A train travels a distance of 2400 km at certain speed. So as I told you, I always teach you by using the framework. So framework is ready. There's a plane which is going onward and return journey. So in the onward journey, it is covering 2400 kilometer distance at certain speed. So we don't know the speed. Speed is in kilometer per hour. So let us take the speed in onward journey as x. Okay. As we know, the time can be expressed as distance upon speed. So here we will take onward journey as t1 as 2400 upon x. As we read the further condition, on return trip due to bad weather, it reduces its speed by 50 km. So on the return journey, again the distance is 2400 km, and because of the bad weather there is a change in the speed is reduced. Let us take this speed as s1 and return as s2. So your speed has decreased by 50, so x minus 50. So the expression for t2 becomes 2400 upon x minus 50. Correct? Now on return journey it took more time, because as you know the concept, in the second case while coming, speed s2 is less, so time, that is t2, will be more. Fine. So let us make the expression over here. It will be t2 minus t1, that is the difference of the time on return journey. It is of how much? 12 minutes. Okay, so let us substitute the values. So 2400 upon x minus 50, this time is more, minus 2400 upon x is equal to, let us convert minute into hours. Correct? Now I'm not solving it further. Now I'm not rolling it down. Let us divide the numerator by 12. So that comes to 200 upon x minus 50 minus 200 upon x is equal to 1 upon 60. Correct, students? Correct? Now let us complete this sum. So here, this will come to 200x minus 200 into x minus 50 is equal to 1 upon 60 up x square minus 50x. Let us complete the quadratic equation. The quadratic equation comes to x square minus 50x minus 6 and 5 zeros, 1 2 3 4 5 is equal to 0. We'll split the middle term. The factor comes to x square minus 800x plus 750x minus 1 2 3 4 5 0 is equal to 0. Let us find the factors. On solving this, we get two factors, x minus 800 and another factor is x plus 750 is equal to 0. So x is equal to 800 watt kilometer per hour, and we also get x is equal to minus 750 kilometer per hour. But this has to be discarded. Speed is not negative. So original speed is how much? Original speed is 8 kilometer per hour. I hope you understood this sum, students. Now we'll proceed with this same type but one more new example. Let us see. Okay. Let us read the sum. As the framework, I have already made it ready because framework makes the calculation easy and understanding easy. It becomes a day-to-day practical example. So let us see. In winter, a train travels at a distance of, okay. So train is traveling in winter and summer. See the condition given to us. The distance covered is 264 kilometer in winter. Okay, in winter at certain speed. So we don't know the speed. So x kilometer per hour. So expression for winter will take as t1, which can be time can be expressed as 264, correct, upon x. But the scene for the summer is something different. In summer, it travels 8 kilometer per hour faster. Okay, so the speed increases. The distance remains same, but in summer, what happens? I think lots of energy. Huh? So it will be whatever speed plus 8 kilometer per hour more. So the expression take as T2 will become 264 upon x plus 8. Let us take this speed as S1 and this speed as S2. Correct. So in this case, S2 speed is greater than S1 and T2 speed more. Correct. So your speed, where speed will be more, speed is there, more speed more time, so T2 is greater than T1. Correct, students? Correct. So here can I put the expression as, is it the speed is more by how much? So in faster it takes 22 minutes less. So speed 22 minutes less, where the time will be, where time will be less, time will, so T2 is less than T1 because your speed is more, so time will be less. Correct, students? So let us make the expression. So the expression becomes 264. Let us write in this format. T1 minus T2. The difference of the time is 22 minutes. Correct? 22 minutes. So let us substitute the values. So 264 upon x minus 264 upon x plus 8 is equal to, let us convert minute into hours. Let us divide the numerator by 22. So it comes to 12 upon x minus 12 upon x plus 8 is equal to 1 upon 60. Correct, students? So now let us form the quadratic equation. Let us put the equation in the proper format. 12x plus 8 minus 12x upon x into x plus 8 is equal to 1 upon 60. Fine. Now let us work on this. This comes to when we solve this, 60 into bracket 12 x plus 12x plus 96 minus 12x upon, we will take that upon up, is equal to x square plus 8. Correct, students? So here this and this will get cancelled. Correct? And we are left with 96 into 60, that comes to x square plus 8x minus 5760 is equal to 0. Now most of the students get jacked over here, but you have to practice this and find the factors. So the factors comes to x square plus 80x minus 72x minus 5760 is equal to 0. When you solve this, you get the factors x plus 80 and x minus 72 is equal to 0. So x is equal to minus 80 and x is equal to 72. We'll reject this because it is negative. So what is the question asking? Speed in winter. Okay, so speed in winter is x. So speed in winter will be speed in winter will be speed in winter will be 72 kilometer per hour. Fine, 72 kilometer per hour. I hope both the examples were similar, but one place where speed was increasing and one where speed was decreasing. Now let us tackle one different type of sum. One different type of sum we'll tackle. Let's see. Okay. Let us see the sum. A boat goes 12 kilometer downstream and return moving upstream to the same spot after 4.5 hours. The speed of the current is 2 kilometer per hour. Find the speed of the boat in still water. Fine. If students just understand this, if the boat is moving in a still water, means the flow of water is not affecting the boat. So boat will move with its own speed. It will move its own speed. But if the boat is moving downstream, okay, when it is moving downstream, its speed gets added because its own speed plus water speed, what speed of water. But if the boat is going upstream, means it is going upstream, so what will happen to the speed of the boat? The speed of the boat will decrease. Got it? Because it is an opposing force. Because it is an opposing force. Correct, students? So because of the opposing force, the speed will decrease. So I made a framework for you. As we will read, we will complete the sum. So here, a boat goes 12 kilometers. So distance, and I have to make it more precise, down speed, the speed is added because the speed of the water will add to the speed of the stream. To the speed of the stream will add to the speed of the boat. And upstream, it will decrease because it is an opposing force. So let the speed of the boat in still water be x kilometer per hour. So here first it is going downstream, so downstream it is 12 kilometer, speed is kilometer per hour and this is r. So 12 kilometer and we don't know the speed, so here it will, now it is going downstream, so boat ka speed plus stream ka speed, so it will be x plus 2 because the speed of the current, the water, this is water speed, so this is speed of the boat plus speed of the current. Why it is added? Because it is going downstream. So what will be the expression for the time? Time will take as t1 as 12 upon x plus 2. I hope this is clear. But now as from when it is returning, again it is covering the same distance, but while coming back it is going upstream. So the speed, okay, x is the speed of the boat in the still water minus 2. Why minus? Because when the boat is moving upward, it is having the opposing force. So T2 is equal to 12 upon x minus 2. Did you understand this? Now, in the whole, when it is refined the speed of the boat instead, when it is covering T1, the time taken for T1, that is upstream and downstream both, it covers how much time, students? It covered 4.5 hour. Okay, so we'll add it. T1 is what? It is 12 upon x plus 2 plus 12 upon x minus 2 is equal to 9 upon 2. Correct? Divide by 3. Dividing the whole equation, divide by 3, the numerator. So what I'll get? It is 4 upon x plus 2 plus 4 upon x minus 2 is equal to 3 upon 2. I'm not rolling down, I'll just solve here. So it comes to 4 x minus 2 plus 4 x plus 2 up. We'll solve, these are the same bracket with opposite sign, so that comes to x square minus y square. That is first term ka square is the difference of the square is equal to 3 upon 2. Correct, students? So here what will get cancelled? Okay, when you solve the bracket, things will get cancelled. You are left with 8x upon x square minus 4 is equal to 3 upon 2. The expression what is obtained over here is 16x is equal to 32, not 32, 3x square minus 12. So let us form the quadratic equation. So the quadratic equation formed will be 3x square minus 16x minus 12 is equal to 0. So let us find the factor. We have to find the factor of 36. Find the factor of 36. And right now I can think of 36 as 18 twos are. So 3x square minus 18x plus 2x minus 12 is equal to 0. So 3x x minus 6 plus 2 x minus 6 is equal to 0. So the factors obtained are x minus 6 and x plus 2 is equal to 0. So x comes to 6 and x comes to minus 2. Okay, the speed of the boat cannot is equal to, this is 3x. X is equal to minus 2 upon 3 is invalid. Fine. So therefore, the speed of the boat which we have assumed as x, so the speed is 6 kilometer per hour. I know students, these sums are little lengthy, but once the concept is clear, it is not at all difficult. So here we found the speed of the boat in the still water. I hope you will practice some more sums of these types. But before starting with the exercise, go through the solved example and then tackle the sums. Thank you, students.